So the next thing we'll look at is the chatellier's principle. You know, we have analyzed an equilibrium system, and we spoke about a system that is in dynamic equilibrium, a chemical system, and the equilibrium constant. Presently, we are going to look at the chatellier's principle, which is a simple principle that guides the way shift in equilibrium of the chemical reaction takes place. The principle states that if an external constraint, you know, if you have a system that is in equilibrium, sometimes there is an imposition of an external constraint. This external constraint can either be a change in temperature, pressure, concentration, or concentration of the reaction. Pressure is more applicable for reactions that are more gaseous in nature, while concentration affects reactions that are solid in nature most times. So when there is an alteration in any of these parameters, the equilibrium position will shift naturally so as to balance or what annul or neutralize the constraint, so that the equilibrium will balance itself back. So this principle is what is known as the chatellier's principle. So we understand when an equilibrium is shifted due to what? An external constraint, the system will balance itself, arrange itself in such a way that the equilibrium is achieved. And it's either favor the forward reaction or what? The backward reaction. The first thing I want us to look at is the effect of temperature in an equilibrium system. We have an equilibrium system and that has to do with the temperature change. The first thing we'll look at is the nature of the chemical reaction involved here. A system can either be what? Endothermic or what? Exothermic. An endothermic system is one in which what? Energy is what? Absorbed into the system. There is a net gain of energy. While an exothermic system is one in which what? Energy is what? Given out. Temperature is lost. So an endothermic system has what? Positive enthalpy, while an exothermic system has what? Negative enthalpy. Now, for a chemical system that is in dynamic equilibrium, when temperature is adjusted, that is the temperature of first an endothermic system. Are we here? So let's write in an endothermic system. Okay, in an endothermic system, when an endothermic system, we said that it proceeds is one in which the reaction proceeds with was net gain in the amount of energy. Do you understand? So such system, if temperature of the system is increased, more energy is supplied to the system, it will favor the forward reaction. It will favor the forward reaction. So let's note that again. Okay. Have we written this part here? Okay. For an endothermic system. So let's analyze an endothermic system. A reaction of this nature. For an endothermic system, when there is an increase in temperature, the equilibrium will shift in such a way as to favor the forward reaction. Please pay careful attention. When temperature of the system is raised, the forward reaction is favored, so there will be more yield of the products for an endothermic reaction. When the temperature is reduced, when there is a reduction in temperature, the backward reaction will be what? Favored. Why? If the forward reaction is endothermic, then the backward reaction is what? Exothermic. So you can note that down. For a chemical reaction or a chemical system is in equilibrium, for a chemical system is in equilibrium, if the forward reaction is endothermic, then the backward reaction is what? Exothermic. For a chemical system in equilibrium, if the forward reaction is endothermic, then what? The backward reaction is what? Exothermic. Do we understand that? Like this case study we have here, when nitrogen reacts with oxygen to give us what? Nitrogen oxide. In this kind of a chemical system, the system here, if you observe, is what? The system here is what? Endothermic. since the system is endothermic, when there is an increase in temperature, what we notice is that the forward reaction will be what? Favored. So there will be what? A net increase in products. Now, if the forward reaction is endothermic, then the backward reaction is what? Exothermic. If the forward reaction is endothermic, the backward reaction is endothermic. So if we reduce the temperature, the backward reaction will be what? Favored. Do we understand that? Next, when we have an exothermic system, one in which there is a net reduction in the amount of energy for an exothermic system, and a decrease in pressure, an increase in temperature. First of all, when we speak of an increase in temperature, it favors first. When temperature is increased, it favors the backward reaction. Why? Because if the forward reaction is exothermic, then the backward reaction is what? Endothermic. So an increase in temperature of the system will favor what? The backward reaction, meaning there will be a net increase in the reactants. Do we understand that? Why a decrease in the temperature of an exothermic system will favor what? The forward reaction. Do you understand that? I will recap that. I said for an endothermic system, when there is a net increase in the amount of energy, an increase in temperature favors what? The forward reaction. Since the forward reaction is what?